Okay, I want to do a little bit of review since we have a few days away over factoring, and then next week we'll add in the next portion of factoring. But I want to go back a couple sections. So if we had a problem like this, all these problem directions will say factor in one way, shape, or another. So we want to first and foremost look at our problems and see, is there something common in all of them? If so, we want to figure out what it is. In other words, what is the greatest common factor? From these, we want to look at, is there a constant term that goes into both numbers or both terms? Constant is a number. So 2 is 1. Is there a larger? So 4. So we want to look at, you don't necessarily have to write it out. I'm going to write it out. There's 4, and then is there a variable? X. And so you take the smallest power, which is just X. So what we did is divide each part by our DCF, and then you write it out in front of your parentheses. So now 4 divided by 4 is, which do we need to write 1? No. X squared divided by X to the first gives us X. We subtract 2 minus 1 is 1. Plus 4 divided by, 12 divided by 4 is 3. X divided by X cancels. So we're left with 4 times X plus 3. That is the factored form. So this times this would give us 4 squared plus 12x. Okay. Now, go back and do a couple of these. We have x squared minus 16. Another word for subtraction is, the answer we get is called difference. This is a square, and this is a square, so this is the difference of 2 squares. Difference of 2 squares gives us 2 sets of parentheses. Square of x squared is x and x. Square of 16 is 4 and 4. Now, because we don't have a middle term in here of x, basically it's like 0x. In order to get that to cancel, we need to have these be the opposite sign. So one of them is plus, one of them is minus. Any of them that are difference of squares, they're going to be plus, going to be minus, as long as this is subtraction. If it looks like this, is that a difference of squares? No. So on this one, we cannot do anything. So this would be one of those where we can't factor, so we would say it's prime. All right, let's do a few more factoring. So these are ones where we look at the factors of the last term. So our factors here in pairs are 1 and 25, excuse me, 5 and 5. Now this tells us we want the pair that adds to be 26, 1 and 25. It's positive 26, so they are both positive. X plus 1, X plus 25. Remember, these two we could switch the order around. That doesn't change anything. So it could be X plus 25 times X plus 1. That does not affect our answer. Okay, so this time we want factors of 12. 1 and 12, 2 and 6, 3 and 4. Factors that add to be 7. 3 and 4, which we need a negative 7. So in order for it to be negative 7, they both need to be negative. Negative 3 plus 4, negative 7. The x minus 3, x minus 4. Negative 3 times negative 4 equals positive 12. And then the last thing we did on Tuesday so we have x squared plus 6x minus 16. So here's our difference in these problems. But again, we look at 16, 1 and 16, 2 and 8, not 3, 4 4 and 4. So we need a pair that subtracts to be 6. Which would that be? 2 and 8. And we need positive 6. So we need 8 minus 2 to get positive 6. 8 plus, or x plus 8. X minus 2. 8 minus 2 is positive 6. 8 times negative 2 is negative 16. And last one we'll look at x squared minus 10x plus 25. So 1 and 25, 5 and 5. You need to add to be 10, so it's going to be 5 and 5. We need negative 10, so it's negative 5, negative 5. So x minus 5, x minus 5. But we have 2 are the same. Should we stop there, or do we need to do one more thing?
Yeah.
Since they are both exactly the same and being multiplied, we need to write it as x minus 5 squared. Okay, so I'm going to have you work on the mixed review today on 219. Extra practice for factoring. So 219. We are going to do 15 through 27 all. I'm not sure if they're all in the back, but even if they're not, we should be able to kind of get it along the way. Okay, so page 219, mixed review, 15 through 27 all.